So here we're told that the first term of a sequence is 2005, and then we're given the specific rule to apply to find the successive terms, which is to cube all the digits of this first term to find the second term, and then repeating that process. If you look at the question, is asking what is the 2005th term. In general, if you see a question that's asking for a term that's far out, it almost always means that there is some kind of a pattern. Because obviously with these types of questions, they're not expecting you to list each one of these 2005 terms. So it's all about establishing that pattern. And so in general, I would say apply the rule up until you start to see a pattern. So here, 2005 is our first term. The second term would be I cube all the digits. And so that's 8 plus, these are just zeros, 125. So the second term is 133. Then the third term would be I cube all the digits of 133. And so that would be 1 plus 27 plus 27, which is 55. And then fourth would be I cube those. And 5 cubed is 125, 2 of those. So that's the fourth term, 250. Fifth term, again, I cube these. And I notice that this is same as the second term. And so that would be 8 plus 125 is 133. And we notice that we're going to just cycle back. This is, again, sixth term would be 55. So essentially our pattern is 2005, 133, 55, 250, then 133, 55, 250, so on and so forth. So that's the block that repeats. The question is, what is the 2005th term? So we know this is the first term. So we need to find the 2004th term in this remaining. So since our repeating block is 3, I'm going to divide this by 3 to see how many of such blocks I can accommodate. So 3 times 6 is 18. 3 times 6 is 18, 24. 3 times 8 is 24. So no remainder, which means that we'll have an integer number of such blocks, meaning 668 such blocks, which means that the 2004th term in this remaining piece would be the last term in that block, which is 250. So the 2005th term of the sequence is 250, which is answer choice E.